All right, so on to part B. We have another function inside of which we have two for loops. So now let's look at their indices. So for the first outer for loop, we're going from 0 to n, and we're incrementing by 1. And for the inner for loop, we're going from I to n minus I, and we're also incrementing by 1. Okay, so this is kind of a familiar case, right? Where right now, if we're just ignoring the body of the for loop, the number of iterations of these two for loops is going to look like 1 plus 2 plus 3 plus all the way to plus n. Okay, and you can actually manually write out what I and j are at each iteration to see this. And basically, this is going to equal n squared, all right? So we know that the number of iterations of our two for loops is n squared. And so now let's examine what's happening inside the body. Okay, so we're doing a call to P, and remember that we can assume every other method call is constant time, so that's not going to really affect our runtime. But because it's an if statement, right, we have two different possibilities of how we can break out of the for loop, right? So if this results in true, that means we break out of this innermost for loop. Remember, break only peels off one layer. It doesn't actually exit out of both for loops. So the best case would be if we return true the very first time we enter the if case, right? So that would be when I is equal to 0, okay? And then we say that j is equal to I, which means j is equal to 0. And P of I, j, n results in true, so we break out of this inner for loop, and so all we have to really do is go through I equals 1, okay? And at that moment, j is also equal to 1, right? And then let's say P of I, j, n is still equal to true. So in other words, P of I, j, n is always going to evaluate to true. So in that case, we know that basically the total number of iterations of our for loop is going to be equal to the number of iterations of I, because every time we enter the j for loop, we only do constant amount of work, right? Because you break out of it immediately. So then in our best case runtime, it's going to be equal to theta of n, which is the number of iterations of the outer for loop. And in the worst case, we're going to have to go through both for loops. And so we said already that it's n squared, which means that the worst case is n squared.